So let's study how we can apply Bayes' theorem to disease testing. So what we can do is we can build a tree like this for problems like this. We know that 2.6% of the population is infected with COVID-19 and that a COVID-19 test correctly identifies 78.9% of positive cases and 97.1% of negative cases. The first question we want to answer is, what is the probability that someone who tested positive has COVID-19? So we can first start with taking all people and splitting them into infected and healthy. The probability of being infected is 0.026. To calculate the probability of being healthy, we can take the probability of being infected away from 1 and get the probability of being healthy is 0.974. Now let's try to figure out the probability of being infected and testing positive. We know that the probability of testing positive conditional on being infected is 0.789. So multiplying these numbers, the probability of being infected and the probability of testing positive conditional on being infected, we conclude that the probability of being infected and testing positive is 0.020514. Now, all of the infected that did not test positive tested negative, so we can subtract the probability of being infected and testing positive from the probability of being infected to get that the probability of being infected and testing negative is 0.005486. Then we can work on the probability of being healthy and testing negative. So we can take the probability of being healthy and multiply it by 0.9701, which is the probability of testing negative conditional on being healthy, to conclude that the probability of being healthy and testing negative is 0.945754. And now the rest of the healthy must have tested positive, so we can subtract the probability of being healthy and testing negative from the probability of being healthy to conclude that 0.028246 is a probability of being healthy and testing positive. So the probability of being infected, given that you tested positive, will be the probability of the outcome of being both infected and positive, 0.020514, divided by the total probability of testing positive, which is the probability of being infected and testing positive and being healthy and testing positive. That is the sum of these two probabilities, the probability of being infected and testing positive and the probability of being healthy and testing positive. And we get a number that's around 45%.